week or today, we're looking at some question, paper 2 questions, should say. All right, let's go. So it says the matrix M is defined as, and we're looking at it there, M is equal to 7 to P negative 1. So we're looking at that. All right. It says here, determine the value of P for which the matrix M does not have an inverse. All right. So we need to understand what it means when a matrix does not have an inverse. All right. Because when a matrix does not have an inverse, it simply means that we're talking about a singular matrix. All right. So it is a singular matrix that does not have an inverse. So here it is that we have a singular matrix, and what the singular matrix says is that the determinant of that matrix must be equal to 0. And remember, we find the determinant by taking the product of the leading diagonal. I have it in red right here, and we want to subtract the product of the non-leading diagonal from that. Now, when it is a singular matrix, that the determinant of M is equal to 0. So that is a singular matrix. So we want to know what value could P be such that when we work out this, we'll get 0. So let us set it up. 7 times negative 1 minus P times 2 should give us a 0. Right? So on that basis, we're going to work that out. So now 7 times negative 1 is negative 7 minus 2P, and this is equal to 0. Remember, we're solving for P. So we're going to be adding 7 to both sides, right? Adding 7 to both sides. Negative 2P is equal to 7. Finally, what we want to do, remember to drop your answers. We want to divide both sides by negative 2. So you could say that P is equal to negative 7/2, or some of us might write negative 3.5, right? So negative 7/2. So remember though that we have to understand the question. They're asking for the value of P that would have caused the determinant to be equal to 0. So the basis on which we rest this is that the determinant must be equal to 0. All right, very good. So I want you to look at the questions as you go and drop your comments as we work through. All right, let's go for the next question. Express the equation 4x minus 2y equals 0, 2x plus 3y equal 4 in the form ax equal b, where ax and b are matrices. Now, what we're going to do is to isolate the coefficients of the x and the y's, isolate them. So what we have is a 4, negative 2, 2, 3, x, y. Whichever variable comes first goes at the top. So the x always comes before the y. So that's why it's at the top here. And this is equal to 0, 4. So the format that they're referring to is ax equal b. And this is what we need to do for that 2 marks right there. That is for the 2 marks right there. They didn't ask us to work it out though, so that's where you leave that. All right, let's continue working. Let's continue working. All right. So at this moment, I'm saying, guess what? Guess what? We want to calculate the matrix product A, B, where A is equal to 1, 1, 2, 3, and B is equal to 1, 2, 0, 1. Giving you a chance to work out your thing. Come on. Try to put it together, see what you can do. All right. So now we're looking at AB. If we're gonna do the matrix product AB, we're going to put the matrix. So we want to do AB. So then we're going to put the matrix A out front, which is 1, 1, 2, 3. So this is the matrix A times B, and this is the matrix B. 1, 2, 0, 1. We're going to multiply these. Remember though, when we multiply, it's row by column, row by column. All right. So then we're going to be using 1 times 1. So I'm going here. Check it out. 1 times 1 plus this one here times 0. So that's the idea, row by column. Also, I'm going to go after that. Let me change the color so you could see what we're going to do. I'm going to go 1 times 2 plus this one times 1. So that is how we're going to be utilizing the idea. All right, so let's follow. So here it is. 1 times 1 plus 1 times 0. So this is my row 1 here times my column 1. Then I'm going to go row 1 times column 2. So it's going to go 1 times 2 plus 1 times 1. All right. So there it is. We have multiplied the first row by the 2 columns. Now I'm going to have to use row 2 with the same 2 columns. So it is 2 times 1 plus 3 times 0. Also 2 times 2 plus 3 times 1. Here it is. From this, we're going to put it together. 1 times 1 is 1 plus 0 here, still 1. 2 times 1 is 2 plus 1, 3. 2 times 2. 2 times 1 here is 2 plus 0, still 2. 4 plus 3, 7. There it is. That's the matrix product A, B. 1, yes, 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 yes. 1, 3, 2, 7. Excellent work. Excellent work. I'm seeing some persons putting out some good answer there. Excellent work there. So that is the matrix product. All right. So then 1, 3, 2, 7. That's what we got. So let me put it right here. 1, 3, 2, 7. We got that. Now, this question here is what we want to focus on after you have found that. All right. So it says, show that the matrix product of A and B is not commutative. That is, AB does not equal to BA. So the word commutative refers to the fact that if I have 2 times 3, I should be able to turn it around and says 3 times 2, and the result would be the same. If that happens, then we say that the matrix or the matrices are commutative, right? So what we're going to do now is to find BA, because we have already found AB. So let's go back here and we're going to work out BA. So this time we're going to put the matrix B first. I'm going to put it in blue this time. All right, so the matrix B is 1, 2, 0, 1. So this is my matrix B. And then I'm going to put my matrix A after that. 1, 1, 2, 3. So now we're doing BA. And we're going to compare. The concept remains the same. My row from the first matrix will be multiplied by the column from the second matrix. So if I should label this, this is row 1, row 2, column 1, column 2, row by column. Let's go. 1 times 1 plus 2 times 2. So I just did 1 times 1 plus 2 times 2. All right, so that's the first one. The next thing that I'm going to do is 1 times 1 over there plus 2 times 3 there. So it's going to be 1 times 1 plus 2 times 3. The next move we're going to make is that we're going to be using the second row because the first row has already exhausted the two columns from the other matrix. So it is 0 times 1 plus 1 times 2. I'm going to put it in black. 0 times 1 plus 1 times 2. Then it's going to be 0 times 1 plus 1 times 3. All right, good. So we're looking at 1 plus 4, that's 5. 1 plus 5, 1 plus 6, that's 7. And then, hold on, 1 plus 4, that's 5, and I wrote 4. Let me write this. 1 plus 4, that's 5, all right? 7, 2, 3. So I'm looking for 5, 7, 2, 3. 5, 7, 2, 3. That's the correct answer there. So then when you compare them, look at this. AB and BA. Here they are. This is BA and that is AB. We could see that they are not equal. And the fact that they're not equal, that means they are not commutative. All right, very good. Let's jump on the other question. So the other question says, find the inverse of the matrix A. The matrix A is 1, 1, 2, 3. So this is the A matrix. 1, 1, 2, 3 is the A matrix. 1, 1, 2, 3 is the A matrix. And we want to find the inverse of this matrix. The inverse of the matrix A, the principle behind the inverse is that we need to have 1 over the determinant of A, and we're going to multiply that by the adjoint of A. So we need to put together that idea. So let us find them piece by piece. We're not in any rush. So we're going to find the determinant of A first. Determinant of A is simply the product. Let me take this off here. Oh, I might need it back. Let me put it back. All right. So it's going to be the product of the leading diagonal, which is these. Product of those numbers minus the product of the non-leading diagonal, which would have been these two that I highlighted last. So then we're talking about 1 times 3 minus 2 times 1. The response for this is 3 minus 2, which is equal to 1. So the determinant of the matrix A is 1. Adjoint of matrix A. The adjoint of matrix A has a principle. We need to switch the elements on the main diagonal. We're going to switch the elements on the main. All right, so let's check this out. So the main would be 1, 3. We're going to switch or swap. So the 3 go where the 1 is and the 1 come where the 3 is. So we're swapping those. And then what we're going to do after that is to change the sign on the non-leading diagonal. So we're going to be changing the signs. So we see we're looking at a positive 1, it becomes -1. Positive 2 becomes -2. So that's the principle for that. So that's the adjoint. So the inverse is a combination of 1, that's right, inverse of A is 1 over 1 times the adjoint, which is 3, -1, -2, 1. But definitely 1 times anything is the same. So the final response is 3, -1, -2, 1. There we have it. There we have that. So that is the inverse of the matrix A. 3, -1, -2, 1. All right. 3, -1, -2, 1. I want to say, I'm looking for a confirmation, confirmation there. All right, good. Yeah. Exactly. All right. Very good, very good, very good. All right, going good. Last question says, given that m is equal to 2x 293, calculate the values of x for which the determinant of m is a 0. All right. So this idea is what we have been doing. We're going to take the product of the leading diagonal here, which is 2x times 3. We're going to subtract the product of the non-leading diagonal, yeah, which would have been the 9 and the 2, and let this equal to 0. So we intend to find what value of x. And then this is the test to see if we understand that that refers to determinant, right? So the determinant is 0. So we're talking about 6x minus 18 is equal to 0. Therefore, adding 18 to both sides, yeah, 6x is equal to 18, then dividing by 6, and then I am getting here that x is equal to 3. So if x is equal to 3, my determinant is equal to 0. All right, good, 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 very good. All right, so that one was about matrix. Matrix comes at number 10, and it is always on the paper. Might not be in that exact format, but it is always there. All right. All right, let's see what's going on again. We are looking at to factorize completely a number of things there. So we want to factorize. So those persons who are on the ball going, I'm trusting that you will work out your factorization right now. I'm giving you a little chance to put forward your answers, right? Put forward your answers on factorization as we speak. Put forward your answers on factorization. Go through and see what you get. All right. So we're going to check this out now. I am looking at, I might just rewrite this right here up top to give me some space to work. So we have x, y to the third plus x squared y. We're factorizing, we're definitely seeing that we have some common factor here. The common factor is actually x and y together. So we're going to divide xy into xy to the third. We're left with y squared. Then we're going to put xy into x squared y, and we're left with x, right? So there it is. X, y, open bracket, y squared plus x is the factored form for that. All right. So there it is. Going, going, going. All right. Here we have another one to be factorized here. This is grouping because I'm looking at 4 terms and I am not seeing anything in common. There isn't one thing that I am seeing here in common, which means that I would have to try to pair them up. So I'm going to see if we have anything in common here, as well as is there anything in common there. So in looking at that, yes, we're seeing where 2h could work for the first piece. So 2h into 2mh, we're left with m, and 2h into negative 2nh, we're left with negative n. Then we're going to take out negative 3. Why am I taking out negative 3? Because I definitely want to ensure that I'll get back a positive m to match back with that. Because if I don't match my second bracket with the first bracket, then it's not going to work. So let's go again. Negative 3 into negative 3 mk. I'm left with, hold on. We left off the k right there. K, yes, right there. Good. So we're left with positive m and negative 3k into positive 3nk. We're left with negative n. Now, as you could see, we do have this and this, which is the same. That means we can refactorize again by writing back the common factor, yeah, and then put the other two things, which are 2h and 3k in the other bracket. So here we go. 2h minus 3k in the other bracket. There it is. We have factorized. We have factorized. All right. Looking at what's going on there. Seeing some answers coming out. Yes. All right. All right. Still going. Going at this one. For this one here, to factorize, this is the highest common factor, 2x to the second. And why am I choosing x to the second and why? X to the second is the lowest power of x in the situation. We have a power here. We actually have x to the third, x to the second. So whenever a letter is a common factor, we have to take out the lowest power of the letter. So x to the second would have been that lowest power there. And then we only have y as the lowest here because this is y squared, this is y. So we're talking about pulling out y. Let's open. We're going to divide x squared into this, into x squared, y. We're left with just x. And when we divide it into this, we have positive 3y. Right? So let's look at that. So when we divide that, we're getting x squared, 2x squared, y, open bracket, x plus 3y. And we would have factorized that. Now for this one here, we're looking at a nice idea. It's called the difference of two squares. What do we mean? We're talking about square numbers like 9. 9 is a result. So I'm just going to list some square numbers. 1, 4, 9, 16, 25, 36, 49, 64, and it goes on, 81, 100, blah, blah, blah. So these are square numbers. So in the difference of two squares factorization, we're going to see two square ideas. For example, you see in the 9 and the 4, and then you're seeing x squared. So when the 9 is combined with the x squared, you get a square term, all right? So the difference means to subtract, and we're seeing that they're subtracted. So this special type of factorization is the one that you can do very easily. Look where they're coming from. 3 square would have given you 9x squared. 2 square would have given you 4. So that's where it's coming from. The moment you understand where it's coming from, those square root are what you're going to put back in the bracket. In the same order, you put a plus, then a minus, and you're done. All right? So we have a plus and a minus. Let me fix this one. A plus and a minus between them. So 3x plus 2, 3x minus 2. Or you might say 3x minus 2 first, and then the 3x plus 2 after. That is just as good. All right. Let us look at these though. We are able to factorize these as is, which means that we're not going to rearrange them. So 4x is my common factor for the first piece, or the first two. So 4x into 4x squared is x, and we have x plus 2, and then we have a minus y, and then minus y, hold on, y is left off here, very good. And then we have x plus 2y going on there. So finally, we would have, let me see where I could write it. Yeah, I could write it here at the back. We would have x plus 2y, yeah? And in the other bracket, you would have 4x minus y. And you could write any one of them first. It's fine. Just make sure that you have them. Just make sure that you have them. All right. These questions come at number 2, though. They are coming at number 2 every year. You'll see them at number 2. Yeah. So coming at number 2. All right. We're looking at solving this equation here. I think I might just push it over a little bit here. So we're solving this. I'm going to write it somewhere here. We could do it off in this little box section here. So let me write 2x minus 3 over 3 plus 5 minus x over 2. This is equal to 3. All right, so now we're going to start the working out. Remember though, that when we're working equation, like rational equations, we don't want to keep the denominators. So we want to find something that could dissolve your denominator and what is called an LCM, but we're not going to keep the fraction. We're going to use it to multiply throughout. Somebody just said 6. So we're going to have 6, yeah, being multiplied by the 2x minus 3. And then we're going to have the 6 being multiplied here by the 5 minus the x. And then we have the 6 times the 3 there as well. Now, the reason why we had to use this 6 is because we want to cancel. So 3 into itself 1 time, 3 into 6 2 times, 2 into itself 1 time, and 2 into the 6 3 times. Let me write this down before I start doing any form of distribution. So after we have canceled, we are left with this. So we're left with 2, open bracket, 2x minus 3 plus 3 into 5 minus x. And all of that is equal to 18. So now we're going to distribute. So we have 4x minus 6 plus 15 minus 3x equal to 18. All right. So there it is. So we're going to combine what we ought to combine here. So I'm referring to 4x, yeah, minus my 3x. And this will give me a 9 equal to 18. So I just combine my like terms, and the negative 6 and the 15 will give me a 9. All right. So finally, 4x minus 3x is x. And if I subtract 9 from both sides, you can see that x is equal to 9. All right. So there it is. X is equal to 9. I'm looking for some confirmation coming out. X is equal to 9. X is equal to 9. I haven't seen anybody post that one yet. Yeah, x is equal to 9. All right, going. All right, let's look at this simultaneous here. We're gonna put it to the, we're gonna put this one to, but we're going left and right here, so we can have some space. So I'm gonna write my simultaneous up top here. It says 3x minus 2y, and this is equal to 10. And then we have 2x plus 5y, which is equal to 13. So this is situation 1, situation 2. Whenever we have simultaneous equation, there are 2 methods that we use to solve them using arithmetic. And one is that we can eliminate one of the variables. All right, so we have x variables here. We could eliminate that. So it's up to us, or we can eliminate the y variable. So it's up to us. Now I'm going to decide which one I want to eliminate since I am working it, right? So I'm going to decide which one I'm going to eliminate. So the thing is, I want to eliminate the y's. So, or let's say I want to eliminate the y's. So I'm going to eliminate these. So in eliminating those, I'm going to create 2 more equations, just a standard procedure. So I'm going to multiply the coefficient, but I'm not worrying about the signs yet. So the 2 is at the top. I'm going to use it down by the bottom. And the 5 is at the bottom. I'm going to use it up by the top. So if you notice, the variable that I plan to eliminate, I will take the coefficient and then interchange, or I'm going to multiply them. So if I take it from equation 1, I use it to multiply by equation 2. And if I take it from equation 2, I use it to multiply by equation 1. All right, hence we end up with this that we have here. All right, so we're pushing further. So we're going to carry out the multiplication. 5 will be multiplied by equation 1. So 5 times 3x will give us 15x. 5 times negative 2y will give me negative 6, negative 10, my bad, negative 10y. And then 5 times 10 will give me 50, and this is equation 3. 2 times 2x will give me 4x. 2 times 5 will give me the 10y, and the 2 times the 13 will give me 26, and this is situation 4. If we look though, if we add, whenever you have different signs, I'm saying to us, let us add for the variable to be 0 paired or to be cancelled out fully or become 0. So again, when you have same signs, you add, but if you have different signs, you subtract. But as you could see, we have, let's go again. I think I said something wrong. If you have different signs, you add, and if you have same signs, you subtract. All right, that's what I meant to say. All right, so you could see here that we have different signs. So with different signs, you add them and you're good. I'm going to write a statement at the back here that I want to add equation 3 and 4. So different signs you add, same sign you subtract. So 15x will be added to 4x. We are suggesting that we'll see that when you add a negative and positive of the same, it becomes 0. So I'm not going to write that because negative 10y plus 10y is a 0. 50 plus 26. Let's carry out this. 19x is equal to 76. We want to divide both sides by 19. So I'm getting x to equal to 4. All right, good. So I'm getting x equal to 4. X is equal to 4. Chad, check your answer. X is equal to 4. Now, I want to substitute. So since I know that x is 4, I want to substitute 4 for x. And I want to do this in equation 1. So let's write equation 1. It says 3x minus 2y equal 10. This is equation 1. I am going to substitute 4 wherever I see x. So we have 3 times x becomes 3 times 4 minus 2y equal 10. All right. So 3 times x becomes 3. Let me highlight it. This is 3 times x. It becomes 3 times 4 because the 4 is taking the place of the x. So let's finalize what we're doing. This is 12 minus 2y equal to 10. I'm going to subtract 12 from both sides. Therefore, this part is a 0, leaving negative 2y equal to negative 2. If I divide by negative 2, both sides, you would see that y becomes 1. My conclusion is that x is equal to 4 and y is equal to 1. Here is the solution for that simultaneous. Here it is. All right. All right, so let us look again on the other one. All right, this one is a simply, call it a simple substitution where we're told that A is equal to 4, B is equal to 2, and C is equal to negative 1. And we're substituting 4 wherever we see A and 2 wherever we see B and negative 1 where we see C. So let's go with the substitution. I have A, so it's going to be 4. Minus B is going to be minus 2. C, which is a minus 1. So if we simplify this, it's 4 minus 3, and the answer is 1. There it is. So I'm getting 1 for that. All right. So the question here is a nicely done coordinate geometry question. So we have a coordinate geometry question. All right, so it reads, the diagram below shows the line segment which passes through points A and B, right? So you're seeing the points A and B that the line segment actually passed through. That's A and that's B right there. So it passes through A and B. All right, let's see what we're about to do. Question says, determine the coordinate of A and B. So we're just going to look. We want to read off. For those of us who don't remember, we're reading from the X first. So look how the points line up. So if I'm reading the point A, the point A is coming from here along with here. But I have to read the X value first. So if you look at that, you're talking about -2 linking with the 3 from the Y. And you get a mark to do that. If you're looking at the B, we're talking about 4 with 6. Remember though, for conventional purposes, the X must be read before the Y. So 4, 6, right? So there it is. You could see our coordinates. We read the X value before you read the Y value. If not, you're going to be in problem. So there it is. We have our coordinates there for A and B. Now we're asked to determine the gradient of the line segment AB. Now you have the coordinates for AB. I could show you, I'm going to show you a quick counting method. So let us do 2 ways. So we're talking about the gradient. Let's push this a little bit to the side. Gradient of AB. Now remember, it's all about y2 minus y1 over x2 minus x1. Concept here is changing y over changing x. All right, rise over run. So let us label. This is x1 followed by y1 beside it. This is x2 followed by y2 beside it, right? Okay. All right. All right, so let's put it together. All right, so we're looking at y2, which is 6, minus y1, which is 3, over x2, which is 4, minus x1, which is -2. All right, so double checking to make sure that we're fine. 6 minus 3 over 4 minus -2. Very good. Remember that these two double negative will give a plus. So we're looking at 3 over 6, which is a half. So the gradient of AB is definitely 1/2. All right. And I know that a lot of people got that. So guys, double check, double check. Let's double check what we're seeing, double check what we're seeing. All right. All right. So we have the gradient of AB to be 1/2, as you could see right here. So we have 1/2. Waiting there. The equation of the line which passed through the point 2, A and B. All right. Now, to write the equation of a line, you need the gradient and the y-intercept. So for this though, if you notice the line AB here, the y-intercept is at 4 on the y-axis. Look carefully, you will see that this is where it passes through the y-axis. All right. So then remember, I want to write the equation in the form y equals to mx plus c. That's the form that I want to write the equation of a line in. But if I have all of these, I'm good, because y is equal to my gradient, which is 1/2 x, and the y-intercept, which is a +4. So this is the equation of the line that passes through AB. Y is equal to 1/2 x plus 4. All right, and there it is. There it is. There it is. All right. So that's coordinate geometry. We're looking at something from statistics now. So we're just looking at random stuff, but we're covering a broad base of topics here. All right. All right, let's go for this stats question. So I'm putting the data out there. Look at it. For those who want to run ahead and deal with their answers before me, no problem. Go. All right, so let's go. The marks obtained by 10 students in a test scored out of 60 are shown below. All right. So this test was scored out of 60, but it's only 10 students, so we have 10 scores. For the data above, they want us to determine the range. Definitely, we need to know what the range is if we're going to determine the range. Our range is always our highest score minus the lowest score. And this is, look for the highest and look for the lowest. All right, I'm seeing the highest score to be 45, and the lowest score look like it's 26. So you have to make sure that you're looking on 45 and 26, right? So 45 minus the 26, 19. So we're looking at 45 minus 26, and I'm getting 19 from a range. So the range is always the difference between the highest scored thing that you have minus the lowest. So the difference between the highest and the lowest is called the range. All right. So there it is. We have 19 as the range. 19. All right. The median. Remember, the median is the midterm, the middle. So in order to do the median, we want to line up the things in either ascending order or descending order. But we must put them in some order in order to get that. All right. So we're going to go, I'm going to put it in ascending order. All right, as we go. Ascending order. All right, let's go for that. Ascending order. That's what we want to put it in. So let's go. What are we looking at now? We're looking at, all right, let me make sure that I cross them off. The lowest one is 26. 26 comes with 29. All right, I hope I don't make any error counting off this. I'm going to mark it off. 26, 29. Normally when I'm doing it, I cross them off so that I don't error, all right? 26, 29, then 31. 26, 29, then 31. Then I'm seeing 35. And then I'm seeing 238, 37, 238. And then, 338, yeah. And then I'm seeing a 42 and a 45, all right? So just making sure, then I'm going to count to make sure it's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I'm sure that it's a 10 scores there. And they're in ascending order. The median is the middle term. So the middle term is going to be halfway. 1, 2, 3, 4, 5. The midterm is right here with these two things here. Because 1, 2, 3, 4, 5, and if you count 1, 2, 3, 4, 5, so we're getting 2. But whenever you get two things for the median, you know, we're going to have to add them and then divide by 2. So you're seeing where we're going to get 37.5. So our median is 37.5. All right? 37.5 is our median. $37.5 is the median. Very good. Interquartile range now. All right. The interquartile range. The word range is coming back. Quartiles. There we have Q1, Q2, Q3, right? So the interquartile range is going to be the highest quartile, which is Q3, minus the lowest quartile, which is Q1. But we're going to have to find them from the data that we have up top. So let me just take out back these things that I have here. All right, let me just put this down on the line. That was the answer for that. All right, so then the median is between 37 and 38. It's neither, it's none of them, it's between them. So this is where the Q2 is, because your median is the middle and the middle is Q2, which is 50% off. So it's halfway between. Now, the median actually splits your data. The median splits your data into two halves, a lower half and an upper half. Now, between this, what we're going to have is from the lower half, you want to find the middle of the lower half. So find the middle of these five numbers. It's going to be 31. This is going to be Q1. So it's the middle of the lower half. And then we'll find the middle of the upper half. I'm going to get 38, and this is Q3. All right. So then now we're going to put it together. Q3, which is 38, minus Q1, which is 31. The interquartile range is 7. Now let's go for this question. It says the probability, we want to find the probability that a student chosen at random scores less than half the total mark in the test. Whenever you're doing these questions, you want to make sure that you really understand what it is saying. So you read it over. If you realize that you missed something, then you want to read it over so that you are on point and see what's going on. So it says the probability that a student chosen at random scores less than half the total mark. Now, we're going to look to see those who score less than half. What's the mark for the test? Go back. The test is marked out of 60. So if the test is marked out of 60, half of 60 is 30. So we're talking about people who score less than 30. This is what the question is based on. Scoring less than 30, less than half of the total. So let's go back to this question. The probability that student chosen at random scores less than half of the total marks. So then less than 30, we're looking at two persons. One get 26 and the other one got 27. So 2 out of what? 2 out of 10 persons. So when we talk about probability, it's the desired outcome, which is 2 out of the total possibility, which would have been 10. This is an answer. Somebody might cancel down and say 1/5. That is correct. Somebody might put it in decimal and say 0.2. That is correct. Another person might look at it and say 20%. That is correct. So all of those answers are expected. Whichever one you choose, you would have been fine. All right. Going. All right, there it is. Measurement question. So this is a measurement question and it reads, measurement question reads, it says the table below, right? The table below, no, my bad. The diagram below shows a cuboid. A cuboid is like a cell phone looking thing, like a duster, an eraser, like a door, you know, that's a cuboid. That's the shape of a cuboid, right? We're seeing some measurements on it. 20, which would have been the height of it. The length of it is 100, and 60 would have been the width or the breadth. How broad it is, no problem. It says, give your answers correct to 1 decimal place, right? Give your answer correct to 1 decimal place. All of our answers will be to 1 decimal place. A straight line or a straight adjustment wire connects R to P. All right, I'm going to do those connections right here with you. So there is a line that connects R to P. I'll take out mine. I might use a broken line, maybe, yeah. I'm going to connect R to P like this. Hopefully it works. All right, there it is. So they just said to us that, hey, a straight adjustment wire connects R to P along the top of the cuboid. Calculate the length of RP. So there it is. They did show us that. All right, no problem. We're looking at it. That blue line that I put up there. Remember though, the key thing for this is that a cuboid is a rectangular prism, which means that it has right angles all the way around. Everything is a right angle. All right, so there is a right angle here. That's a right angle. Because it's rectangle, so everything is a right angle. Every corner is a right angle. I'll just say that. Every corner is a right angle. So because of that, remember this 60 is 60 here. All right. And this 100 here is 100 here as well. So because we have all right angles all the way around, we are able to find the distance from P to R or R to P, because it's like the hypotenuse of a right angle triangle. This is the hypotenuse. Let me write it, hypotenuse on my blue line. So that blue thing that I put there is the hypotenuse. So basically then we can now use the Pythagoras theory to find it, because the hypotenuse, which is RP, the hypotenuse square is equal to 60 square plus 100 square. 60 square is going to give me 3,600. 100 square should give me about 10,000. So then we're going to be dealing with 13,600. So to find the answer, it's going to be the square root of that. So that is the Pythagoras theory we're using there. So finding the square root of 13,000. All right, somebody work it out. Yes, Pythag, yes, yes. The square root of 13,600 is 116. So I'll write what I get. Definitely, I got 116.61. But instruction says 1 dp. That means the answer is 116.6 centimeters. So the hypotenuse here in blue is 116.6 cm. So we have 116.6 cm for that hypotenuse there. Anybody work that out as yet? All right. Remember though, the reason why I know it's a right angle is because of the nature of this diagram. It is a cuboid, but it's a rectangular prism. So that means the edges are right angle. The vertices, they're right angles there. Let's go for the next question. So I'm going to go up and down this diagram. It says the connection at P is now adjust and moved to T. So that we're going to move that thing at P and move it down to T. And then we want to look at RT. So look. So I'm going to move this. I wanted to see what's going on. I'm going to take off these numbers so you could see clearly, so you can understand what's going on. This is move from P. See there, I'm taking it off P, yeah? And I'm going to move it down to T. That's what they're saying there. All right, so they move it down. All right, you might not be able to see it very well, but you could see that I moved it from P up top. So it's coming slant in the ear. Like, look, it was at the top at the surface here. It's like I'm taking it down like that. And I'm not taking it here to W, but I'm taking it across to, so I moved it all the way down. Look, it came down in the middle on the ground, and I'm walking it to T right there. All right. So now you can imagine what's going on. So I'm going to try to create a triangle down there for you to see what's going on. So it came down on the ground. It's like the top of your room in a corner going down to the other diagonal on the ground. So you're moving from top in the corner to on the ground in the corner. So that's the thing you're looking at right now. Now, so they want us to calculate RT. As I said to you, every corner of this diagram is a right angle. So I'm going to put on another, line for you to see a little bit more the triangle that was formed. Look, I'm putting on this for you to see. So this is on the ground. Imagine I'm moving on the ground. This is on the floor. This red line I'm going to put now is on the floor. So it is on the floor. So what happened is that the red line on the floor, let me see if I can help you out. The red line on the floor links with this to get a right angle right there. And the blue line coming from up at the top, coming down to the ground here. So you could see it's coming like through your room on the ground. So it's another right angle triangle that you're getting. And with that right angle triangle, you do realize that this is still 20. But you see this distance from T to V on the ground, the red one that I put on, it was what we found up top from R to P. It's the same thing. So I'm going to call it back 116.6, because if you look at the shape of the thing, from P to R is the same thing as from T to V. No. So now we're finding a diagonal, which is the hypotenuse again. So we actually have 116.6 and 20. And we're going to use that to find the hypotenuse again. So if you look, it's another hypotenuse I'm finding. My blue line is another hypotenuse. So let me minimize so that we could work the problem here. Let me minimize again. I hope we're seeing. I could work it up there. So let me see what they asked us for. RT. So let me just work RT, please, up there. All right, so RT. Here, we could work RT beside it. Yes, right here. So I want to work RT here. RT. RT is the hypotenuse. This blue line is an hypotenuse. Look at what I created. It's the hypotenuse. So RT is equal to 116.6 square plus 20 square. All right. I think this is going to give me 13,600 or 13,000 near to that. 116.6 square, 13,595. I'm working with 13,595.56 plus 400. All right, so this is 13,995.56. Let me fix that. And then now RT is going to be the square root of that. 118.1, 118.3, So that distance coming down is 118.3, all right, to 1 dp. I don't think I'm going to label this diagram because they're going to do more thing on it. So that is the slanting coming down from top, coming down there, 118.3. Yes, yes, yes. So this is 118.33 that we got there. All right. See ya. All right, good, 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 good. Calculate the angle TRV. TRV. So let's look at it. TRV. I'm going to pull off some of these things. TRV. TORV. All right. That could stay. So we want an angle right here from TRV. So it's the blue line that I have to the 20 to the red. So we want that angle up there, but we have the sides. All right. So you have every side. So we can do anything to find TRV. So if I'm using the 20, and so I'm going to focus on the 20 that is already here and the 116.6, and I will use that. If I'm going to use that, it's a tangent. So it's a trig ratio, but it's going to be tangent to give me that angle, because the 116.6 is the opposite to that angle up there. And then that 20 is actually the adjacent for it. All right. So we're using the tangent. So we're going to say tangent of any angle in a right angle triangle is our opposite side divided by the adjacent side. Now it's going to be the tangent of something that we intend to find the angle, which is the opposite side, which is 116.6 over 20. Let's find what that value is. All right, so 116.6 divided by 20, and all right, divided by 20. Hold on, 116.6 divided by 20, and I'm getting about 5.8. EJ, come fix this. All right, tangent is gonna give me 5.83. So I'm going to have to use the tan inverse, or what people call arctan. So inverse of 5.83 is 80.26, but I'm going to put 80.3 to 1 dp. 80.3. A minute gone. 80.3. How do I pass it again? All right. Because that's a 4.463 that I use. All right. Let me fix this. I don't want people to think that is so it's 80.3 that I got. Let me write it. So the answer for angle TRV, I got 80.3 degrees. That's what I got. 80.26, but they say 1 dp, so it's 80.3. Yes. Very good. Very good. So that's how you have to put it together. Just open your eyes, look at what's going on, and work. All right, just work. All right, good. Good. Let's look again. So we just found that. All right, let's complete these statements. It says complete the following statements below. All right, it says the size of the angle through which the wire moves from R. So we're looking at the side. Oh, say it move from RP to RT. What is that angle? Let's look. Have a look at the diagram. All right, so we need to look. Say it move from top to bottom there, they want to know the size of the angle that it moves from top to bottom. Okay, it's gonna be the remaining piece of angle from RP to RT. Okay, all right, let me see if I could fix this for you so that you could understand. Let me create a better diagram now. So there is a R, there is a, so this is, let me just show you what's going on. R is up here, there is a V down here, and technically this is what happened here, all right? And then there is a T here, all right? You know what? Let me move it from there. I need space. Let me get myself some space to just show you quickly what happened. Yeah. Yes, I'll show you right here. So that you understand this last question, or this question. We have R here, and there's a V down here. This is basically a flat thing, even though you're not seeing it. So this is T here, but originally, all right. So this came down here. It's like it came from P and came to T. So this was a P to T. Now they're asking us what angle did it move through to come down. That's what they're asking, that angle. Remember though, you know, we just found this to be 80.3. We found this to be 80.3. And I wanted to understand that this is also 90. So it came down, you know, a little 9.7 right there, because everything there would be 90. I want to understand that it was originally here, and then you walk it down here, created an angle here. And that's the angle you're asking for right there. That angle is going to be 90 degrees minus 80.3 degrees, and I'll say 9.7 is the answer for that, all right? So it came down 9.7. 9.7, so let me put that answer there. 9.7. So it moved from RP to RT is 9.7 degrees. So that's the angle that it shifts down. All right. The angle which is the same, in size as RTV is what? RTV. So we have to mark RTV. RTV. Where's RTV? R, T, and V. Okay. So the angle which is the same as RTV would have been, okay. Let's look careful at this. The angle which is the same as RTV. All right. All right, so you have to look carefully at this. So they want an angle which is the same as, where's R? RTO. All right, so they want an angle which is the same as this. Look now, I want you to look. They want an angle which is the same as RTV, this. I want you to look carefully. Please look. Now, I'm going back to this diagram because it's hard to see on that shape. So remember now, RTV, look, RTV is the same as 9.7, and this up here was 9.7. So it's not a big question they're asking. So you could see that sort of Z angle coming out now. So look at it carefully. It's a good thing we have the diagram here to, you know, have a look so you could see it properly. So you could say TR, PR, you could say, so you could write it two ways. You could say angle PRT. If you don't want to say that, you could turn it the other way and say angle TRP. But R is in the middle of those two letters, the T and the P. That angle is the same as the RTV. So any one of those you want to write, you'll get the answer. This, or you want to write that, and you're seeing it here. Z angles are equal. Yeah? Excellent work, excellent work, excellent work. Very good. Very good. So you see, sometimes they ask back some of these little questions, you know? So you have to be thinking. You have to be thinking. So I'm just going to write TPR. So I'm going to say angle TRP, should say RP RT. Anyway you want to write it, right? You're good to go. But that is the angle up there, which is the same down here. Hold on. Okay, yeah. All right, so we're good. Right, so there's some function questions. Yeah, we haven't done any function in a while. All right, so moving on some function question now, function questions. Let us see. Function, it says the function f is defined as f of x is equal to 1/3 x minus 2. Find the value of f of 3 plus f of -3. You're going to evaluate these functions, evaluate them. So let's write the f function. F of x is equal to 1/3 x minus 2. So we want to find f of 3, which is equal to 1/3 times 3 minus 2. As you could see here, we could employ some canceling. 3 into itself 1, 3 into itself 1. So we have 1 times 1 minus 2, I'm getting -1, right? So I'm getting -1 for f of 3. So f of 3 gives me -1. Let me mark my answer there. So I'm telling you that f of 3 gives me -1. All right, let me go for the other. So f of x is equal to 1/3 x minus 2. So if I'm doing f of -3, I'm getting 1/3 with a -3 minus 2. This into this one, this into this one. So we're talking about -1 minus 2, which is -3. So then let me write this. F of -3 give me -3. F of -3 give me -3. So then in putting together what the question asks, this is -1 plus -3, and this is -4. All right, guys, so we're getting -4. All right, so we have -4 there coming out, -4. So when you combine those, we get -4. Double check here and see if you got it, if everything is fine with that. All right, so I'm pulling on. Calculate the value of x for which f of x is 5. All right, so then what they're saying is which value I could have put here and work this out such that my answer is 5. So in order to do this, what we want to do is to equate the f function to 5, because that's what it is. So remember now, the f function is 1/3 x minus 2. Let that equal to 5. And from here, we want to solve for x. So what we're going to do is to multiply, put every single term by 3 in order to get rid of that fraction. So 3 cancels itself there. 1 times x give me x minus -2 times that, -6 equal to 15. Add 6, add 6. X is equal to 21. So what this is suggesting, is that if I put 21 where x is, right? 21 where x is, then I would work out and get 5. All right, let's continue working. Sorry. All right, let's go. All right, 21. Let me see who got 21 there. All right, let's check. Determine the inverse of f of x, 1/3 x minus 2. All right, I'll put it here. Inverse of f. What's the concept of the inverse? One has to know the concept of the inverse. So if f of x is equal to 1/3 x minus 2, remember though that if we're going to do the inverse, we want to let f of x equal to y such that we can rewrite this and say y is equal to 1/3 x minus 2. All right, so you don't have to write this statement. This statement is written for instructional purposes. Y is equal to 1/3 x minus 2. What is the idea behind the inverse of a function, or finding the inverse, is that the x and the y switch. For example, if I have a point and the point says 1, 2, the inverse of that point is 2, 1. So when we're dealing with the inverse, the x will go where y is and the y go where x is. So we would say that the x and the y swap. All right, so there is swapping going on. We're talking about the inverse. The x and the y will swap. So now we're going to employ that swapping. So there is a two-step process. One, we're going to swap x and y. Two, we're going to, so after swapping x and y, we're going to transpose for the new y. So let's deal with the swapping now. Swapping comes with rewriting this. So we're writing that y, well, not y anymore. It's going to be x is equal to 1/3 y minus 2. And then now we want to transpose to make y the subject. So we're going to be adding 2 to both sides, as you could see. So we have x plus 2 is equal to 1/3 y. Okay. And then you could multiply both sides by the 3. All right. So multiply everything by the 3 there, as you could see. All right. Times 3. Put this in a bracket. Times 3. All right. So we times 3 there. So what we're going to get is actually 3x plus 6 is equal to y. Some of you might have, so when you finish though, please write back what they had asked. The inverse of f of x is 3x plus 6. All right. So that's one way. Some people, after you reach a certain place, for example, when you reach here and you have x is equal to 1/3 y plus 2, you can multiply through by the 3 as well, you know. So I'm giving you or if you never wanted to do it like that down there. So you would have had 3x equal to 1/3y times 3 plus 2 times the 3, because you have to multiply everything. The 3 cancel itself. So you're going to have 3x, which is equal to y plus 6. Hold on. Okay, this is a minus 6 here. All right, give me a quick, I think I wrote, because I'm saying I wrote something wrong. Let me just fix it quickly. That's a minus right there. Minus. Let me fix this. Minus, that's a minus. Minus, good. So there it is, the minus 6. And then we're going to be adding 6 to both sides so that the y is alone. So we have a 3x plus 6, and that is equal to y. Therefore, we could say the inverse is equal to 3x plus 6. So I was just saying that it doesn't matter how when you reach certain place, your methods, just get there and make sure that, you know, you're not making any error and you're good to go. All right. All right, so that's the inverse there. Moving up some more. What question is coming? Oh, it looks like it's another coordinate geometry, but it looks different from the one that we did before. So let's go. All right, it says the diagram below shows the graph of the straight line x plus y equal 3. So that's the line, x plus y equal 3. So they are saying that determine the equation of the line which is parallel to x plus y equal 3 and pass through the origin. All right. Now, why are they giving us parallelism here? Because when lines are parallel, so we want to remember that parallel lines share the same gradient. Yeah. So because parallel lines share the same gradient, we can use it. But I need to write this in a way to accept the gradient. So for me, I love to have y by itself. So you'd migrate this to the other side by subtracting x from both sides. So it's minus x plus 3. And remember that the gradient is the coefficient of the x. So the gradient is the number in front of the x, which is a -1. So then for the original line, this line, I could call it M1, the gradient is -1. Now, if there is another line that is parallel to this, its gradient is -1 as well, right? So if the question says that the line passes through the origin, the coordinate for the origin is 0, 0, which means that the y-intercept is at a 0. What is the equation? Determine the equation of that line. The equation of that line is simply going to be y is equal to the gradient, which is -1, x plus 0, but we're not going to write plus 0. So it is okay to say y is equal to -x. Next question. We want to determine the equation of a line which is perpendicular to this same line here and passes through the midpoint of AB. All right. Now there are two things we need here. We're going to need that point that it passes through, and we're going to need the gradient. Now the gradient is going to be the negative reciprocal of this. Hold on, let me fix this. It's going to be the negative reciprocal of this. Negative reciprocal of that, which means it's going to be a positive one. So for this perpendicular line, all right, if you allow me, I'll just write M2 for the gradient, yeah? So the gradient for this is going to be +1, but I need to know the midpoint coordinate. So I am going to have to look, or I'm going to have to calculate it, all right? Well, it's right here, but right here, that's it, right there. That's the middle of the line. Basically, it's 3, 0, but we could work it out. The midpoint coordinate, yeah? The midpoint coordinate is like this. x1 plus x2 over 2. Talking about the coordinate of midpoint. y1 plus y2 over 2. So A is, see there, it's 0, 3, yeah? And B, hold on. Oh, it was AB, so that wouldn't be the midpoint anyway. Hold on, let me take off this. So right here, let me mark the coordinate at B. This is 3, 0. All right. So these are the coordinates. At A, we have 0, 3, and at B, we have 3, 0. All right. So it passes through the middle of AB. So let's go for it. So the middle of AB is somewhere here, but we can calculate it. Let's just label these quickly. X1, Y1, X2, Y2, X1 plus Y1, 0 plus 3 over 2, Y1 plus, so we have 3 plus 0 over 2. So you realize that it is at 3 over 2, 3 over 2. Some people might say 1.5, 1.5, same thing. So that is the This is the point that it passes through. That's what it passes through, 1.5, 1.5. So we want to take these two things now and write the equation of that perpendicular line. So then, remember though, y is equal to mx plus c. All right, so we could try to find c if we want by using these. So y, which is 1.5, is equal to m, which is 1, times x, which is 1.5. Yeah? All right, plus c. So y is equal to mx plus c. 1.5 is equal to 1.5 plus c. So you could see that subtracting 1.5 from both sides, yes, will land us a 0. All right, so 0 is equal to c. So then, the equation of this is simply y is equal to x. All right, so we get y is equal to x for this one. So one of them is y is equal to negative x, and the next one is y is equal to x, right there. So sometimes that is how the equation looks, because we have a plus 0 at the back and a plus 0 at the back. You don't need to write plus 0. All right. All right, so there we go. All right, I think we did these already. No. Oh, everybody is slightly different, eh? Oh, it's solving. Let's go. All right, let's just run through these still. All right, we did some factorization, but we still could just do this. So this one here is the difference of two squares, again, as you could see. So we just open two brackets, yeah? 1, 2h, 1, 2h. Where did we get these? It's the square root of those. Square root of 4 is 2, square root of 8 square is 8. Put a plus, put a minus, and then that's that. It's a 1 mark question. For these, you want to pair these up, you want to pair these up. So taking out q, p minus q, and then taking out a negative 3, so we get a p and a minus q again. Then now you could just write back 1, p minus the q, and then the other two things, which is q minus 3. And we would have factorized that. Solve. So we're solving some stuff here. For this one that we're solving here at B, we're going to get rid of the fraction. So you just multiply both sides by 2 so that we could cancel this on the left side. So we have 3y is equal to 12. And if we divide both sides by 3, we will see that y will give us 4. All right, good. All right, so what we're going to do for this now is we're still solving. We have 2x squared plus 5x minus 3 equals 0. A is 2, B is 5, and C is -3. It's a quadratic equation. And in order to solve the quadratic equation, you could employ your factorization skill if it can be factorized, and it can. And you could use the formula. I'm going to factorize it. So then I'm looking at AC, and AC is 2 times -3. It's a -6. My factor pairs are 2 and a 3 and a 1 and a 6. Both of them could give me a 5. However, since the AC is negative, it means that 1 is positive, 1 is negative. And then when 1 is positive and 1 is negative, only a 1 and a 6 can give me a 5. So the 3 and the 2 cannot give me a 5 when 1 is positive and 1 is negative. Can't. Now, since I know that it's 1 and a 6, the bigger one must take any sign that B has. So it will be a -1 and a +6. So let's put them in. What are we looking at? We're looking at, let's go. We're looking at 2x squared minus x plus 6x minus 3 equals 0. Factorize these, factorize these. X, I'm getting 2x minus 1. I'm getting 3, which is +3. And I'm getting 2x and then a -1 equals 0. So I have 2x minus 1. And then I have x plus 3 equals 0. And then whenever you're solving, if two things multiply to give 0, then we're saying either one of them is a 0 or the other is a 0. So from here, what we're doing now is that we're going to be solving. So 2x is equal to 1 by adding 1 to both sides. Yeah, dividing by 2. So x is equal to 1/2, or you could say you -3 from both sides. So x is equal to -3. So the two responses that we have here is x is equal to 3, x is equal to 1/2. All right. All right, so let us go to this one that says the quantities f, m, u, v, and t are related to a formula. And here is the formula. Find the value of f when m equals 3, u equal -1, v is equal to 2, and t is equal to 1. All right, so we're going to substitute. Let's substitute beside it. M is 3, open bracket, v is 2 minus u, -1, all over t, and that is 1. So we're having 3 times 3, because these will turn into plus, then the answer is 9. So I'm getting 9, I'm getting 3 outside, yeah? 2 minus minus, yeah, that becomes 3. So I'm getting 9. Somebody double check that quickly. In the meantime, what they want us to do here is to, we want us to make V the subject. So let's put this here. So if I have F is equal to M V minus U all over T, and I want to make V the subject, I'm going to get rid of the fraction first. I'm going to multiply both sides by T in order to cancel this T. So now I have FT or TF, which is equal to M times this. I'm going to distribute the M inside right now. So you're talking about MV minus MU. Remember, we're focusing on isolating the V. But there's a principle in the transposition game that says leave the subject and anything directly attached to it for last. So it means then I'm going to leave that. So I'm going to work on getting rid of that negative mu. So it means then I'll be adding mu to both sides. So then ft plus mu is equal to mv. Then I'm going to divide by m because the aim is to have v by itself. I could finalize by saying v is equal to ft plus mu over m. Okay. Oh, somebody says 8. All right. All right. Somebody is asking me to double check something. They said it should be 8. All right, let me double check the numbers. So I'm going to do a quick check. M, where's M? M is 3, so 3 is all right. Open bracket, V, where's V? V is 2. And then there's a minus in it, and then a minus again, 1. So this becomes 3 here. And we're going to divide. 9 is correct. 9 is correct, guys. All right, good. All right, let me see how we can do this. All right, let me blow this up for us. All right, let me shift it. All right, right there. All right, that should be big enough for us. All right, good. All right, so the next question says, the matrix A and B are given as, so the matrix A and B are given as A is equal to -1, 0, 3, 2, and B is equal to -3, 2, 1, 1, 4, 6. All right, 4, 6, 4, 6. So then, first question is to find the inverse of A. All right, so if you find the inverse of A, we're looking at inverse of A is going to equal to 1 over the determinant of A times the adjoint of A. Let's find the determinant of A. The determinant of A, I'm changing how I write the notations for it, is -1 times 2. So that's the product of the main or the leading diagonal minus the product of the other diagonal, all right, which is these numbers here, which is a 0. So you're looking at -2. So the determinant of A is -2. You want to take note of that idea for now. The adjoint of A, we could put it right here. So the adjoint of A is when we're going to switch the elements on the main, which is a 2, take the place of the -1. They switch. And then we're going to change the signs of the other elements on the other diagonal. All right, so there it is, we have the adjoint. The principle of the inverse is just to fuse together this idea. So it's 1 over the determinant, and you're putting that beside the adjoint. Technically, this is already the inverse. But we are gonna distribute that -1/2 inside, which means that you will have 2 over -2, 0 over -2, -3 over -2, -1 over -2. And then what we could do now is just to finalize it. This is -1, 0, +3 over 2, +1/2. All right. All right. Hopefully, if we made no error there, that is actually the inverse of A. -1, 0, 3 over 2/2. Show that the inverse times A gives us back what is called the identity matrix. So the identity matrix is 1, 0, 0, 1. That's what it looks like. So we want to basically work and prove that this is it. Now, if we have made any error up here, like with numbers, it won't work out any at all. If we make no error, we're good to go. All right. I don't think any errors there. That's negative that, switch that, but doesn't look like there is any error. Let's go. So we're going to take the inverse, which is this, -1, 0, 3/2, 1/2, and we're going to multiply this by the original matrix. Let's go for it. Let's look at it. -1, 0, 3, 2. So we're going to take these. All right, so we're going to take that, we're going to multiply them and prove that we'll get that. Right? So let us take our time and work this out. Remember though, it's row by column. Here are my rows and here are my columns. So let's go for it. -1 times -1 plus 0 times 3. So it's row by column. What I just did, -1 times -1, 0 plus 3, and we picked up that already. Let's go for the next row by column. -1 times 0, 0 times 2. So we're going there for the next working out. All right. So let's go. -1 times 0 plus 0 times 2. And let's go further. 3/2 times -1 plus 1/2 times 3. 3/2 times 0 plus 1/2 times 2. All right. All these numbers, they may look ugly, but I'm seeing the answer already anyway. Now let's take our time. -1 times -1 is +1. This 0 times the 3 is 0. So we have a +1 here. Anything times 0 is a 0. So we get back 0 there. You could see here that we have these. This is a -3/2, and this is going to be a +3/2. So negative and +3/2 will give me a 0. And definitely we're seeing here where this part here, this is a 0. And then I'll have, when you cancel down this, you'll get 1. So you could see that it really works, right? We were expecting it and we got it. Hence the proof, right? So we actually prove that the inverse of A times A gives us the identity matrix. This is the identity matrix, and we do call it I. All right, so they said do A square. I always like to go back for the matrix. -1, 2, -1, 0, 3, 2. A is -1, 0, 3, 2. If we're asked to do A square, then it means A times A, which means that we're going to have -1, 0, 3, 2 times -1, 0, 3, 2. One of the problems that we see with these is that people think that they need to square the elements inside. No, it's not about squaring the elements inside. The concept of a square is that the thing is being multiplied by itself. Hence, we're going to have to do that, right? All right, let's go. Row by column again. These are my rows, and I'm going to use them on my columns here. So we're going for that. -1 times -1 plus 0 times 3. -1 times 0 plus 0 times 2. Next, 3 times -1 plus 2 times 3. 3 times 0 plus 2 times 2. Let's go down some more. Finally, this is a positive 1 and a 0. This is 0 and a 0. This is -3, +6. So that's a +3, because a -3 plus 6 is a 3. 0 and a 4 is just a 4. There it is. So don't think that, you could just square them and it works. It's not the same. Even if one thing is off, it is off. So we're expecting you to multiply a matrix by itself if you're asked to square it. Guys, those of you who are here, remember, if you haven't hit the likes, please do so. All right. Explain why the matrix product AB is not possible. Let's go for AB. Why AB is not possible? So we have to actually look at the matrix, A and B. All right. Now, this is why it's not possible. A and B. Matrix A is a 2 by 2 matrix. Matrix B is a 3 by 2 matrix. Now, the idea is that if I write the order of the matrix, or the matrices, if I write the order of how they will be multiplied, and the inner numbers are not the same, I highlight them in yellow. If the inner numbers are not the same here, then it's a no, it can't work. In other words then, if the number of columns from the first matrix is not equal to the number of rows from the second matrix, then we cannot multiply them. Hence, why this one could not be multiplied. So they are not conformable for multiplication. All right. I'll say the number of columns from the A matrix is not the same as the number of rows from the second matrix. And I'll say B. So basically, based on how it's set up, understand? And I'll rewrite it for you. There's a 2 by 2 and there is a 3 by 2. We're suggesting that these numbers, they are not matching up, so it's not conformable for multiplication. Without calculating, state the order of the matrix BA. Now, the matrix B is a 3 by 2 matrix. So this is matrix B. Matrix A is a 2 by 2 matrix. So hence we have BA. These two numbers here will tell you that it can work. All right, so normally say, okay, yes, it can work. All right, so I'll say yes. However, these two numbers here are the result. So when you multiply these two matrices, you will get a 3 by 2 matrix. So the n numbers, you have to make note that the n numbers will give you the new matrix. So that's the new matrix. Yeah. So when AB multiply, I will have a 3 by 2 matrix as the product. Responding to these questions right there. Just trying to give some detailed explanation for stuff, right? Detailed explanation. We have about 5 minutes to wrap up, right? Have about 5 minutes to wrap it up. All right, so we could brush off this question here, take us home. Tomorrow we're coming with more questions. All right. It says the diagram below, not drawn to scale, shows a triangle PQR, which represents the cross section of a roof. QS is perpendicular to PSR, and we get some measurements right there. The question says, using the dimension shown, calculate correct to 3 significant figures. The length of QS. Now, I'm looking at QS. I'm going to isolate the triangle that will help me to find QS. So that green triangle there, as you could see, I have the hypotenuse for, and they're asking me to find the opposite side. So whenever I have a right angle triangle and an angle is involved, I'm going to think of my SOHCAHTOA, which is my trig ratios. So then the sine, I'm going to use the sine rule because I have an opposite side to deal with and I have an hypotenuse side. So I'm using sine. So the sine of 15 degrees is equal to QS over 12.6. Now remember, I need to find QS. So I'm going to multiply both sides by 12.6. So 12.6 times the sine of 15 degrees. And I'm looking at 3.2611. But remember that they did say to us 3 significant figures. So it is 3.26. This 6 is in the third spot. And the 1 that comes after it will leave the spot because 1 is in the 0 to 4 category, so it cannot move. It will be rounded down. You understand? Because the 1 is in the 0 to 4 category. So QS, I will label it here, is actually 3.26 meters. All right, let's go for the next. Next question says here, the measure of angle RQS. Where's R? RQ, this angle. So they want RQS. Well, I'm going to use, so for this angle, this side right here is actually the adjacent side to it. And I have the hypotenuse for that triangle. So adjacent and hypotenuse is Ka. All right, so I'm going to use the cosine ratio to work that one out right there. So basically, we're saying the cos of the angle that I don't know yet is equal to 3.26, which is the adjacent side over the hypotenuse side, which is that. So we want to find out what this value is, yeah? All right, so basically then, I'm having here that the cos of the angle is 0.3880. 881. Let me write it properly. All right, well. So then I have to take cos inverse of 0.3881, and it's going to give me that answer. So we go cos inverse 0.3881, and I'm getting 67.16. But three significant figure, 67.2 degrees for that angle up there. All right. Next question says, find the area of triangle PQR. PQR. Remember though, that if you're going to find the area of a triangle, there are trig formulas that will help you to find the area of the triangle. All right. So watch this. This is going to simply equal to half AB sine C. We're going to utilize that trig formula to find the area of the triangle. We only need to find this angle here, which is 75, because this is 90 degrees here, and we have 15 here. That means the remaining piece for that is 75. Why am I doing that? It's because I know that over this side, we just worked it out and got 67.2 degrees for that angle. Now, why are we doing this? If you have an angle, between two known sides, you can use that to find the area of the triangle using a trig function. So this is 142.2 altogether. So because I have the angle between these, I am able to utilize this formula down here by saying a half times 12.6 times 8.4 times the sine of the angle, and it's going to give me the area immediately. So that is something that we want to make sure that we have, using trigonometry where necessary to find the area of triangles. I am getting 32.43, but remember, three significant figures, 32.4 square meters. And there we have it. There we have it. Have it. All right. All right. So, all right, we're gonna end this one there. Tomorrow is gonna be the last one. Invite as many people as you can. We're gonna do the last one. We're gonna do a mixture of questions. We're gonna do a little multiple choice, a little of every little topic, one piece. So you can invite as many persons as you can out to tomorrow. It's gonna be the last marathon before the exam. So I guess I'll see you guys tomorrow again, and bring along a friend. Remember to bring up the likes before you go. Hit the likes when you're leaving. And I'll see you guys tomorrow. Same time, 6 p.m. And the link is the same. You just come on the YouTube channel and it's there. See you guys tomorrow. Revision 5 and 5 is tomorrow.